Good morning once again. Today we're going to discuss vector autoregression models, and I hope you have already loaded the RMD file. Okay, so let's just quickly. I'm already giving you the file. No need for you to type because we really lack time already. So as I said, VAR models, vector autoregression models, are used for multivariate time series. So far, what we have done, yung ARIMA natin, no, yung AR process natin, ARIMA, they're just univariate, no? Univariate, isang ano lang, isang variable lang yung model natin. Kunyari, yung log ng air passengers dati, di ba? O kaya yung returns ng Google, returns ng Yahoo, returns ng any stock. That's a univariate model approach. Meron tayong tinatawag na multivariate naman. So VAR is an example of a multivariate. Okay, so itong multivariate class, parang combination siya ng regression. Kasi we're regressing a particular variable based on autoregressive siya, di ba? Past values of itself and also past values of another variable. Okay, of other variables. So for example, let's say you have three variables, x1, t, x1, this is the first variable at time t, x2, the second variable, and the third variable. All of these are time series. So if we're going to create a var model out of this, ito yung model natin. So we can predict the value of your x1. x1 is a variable, no? Pwedeng GDP yan. Pwedeng x2, inflation. Pwedeng x3, let's say unemployment. So we have three variables here. We're trying to look at the relationships among these three. Now notice here, wala tayong sinasabing particular na structure. Hindi natin sinasabi na si employment, si unemployment causes say GNP, no? Or GDP. So dito parang agnostic tayo sa relationship nila. When you say agnostic, unlike pag OLS, di ba, kailangan na define muna natin yung structure. Tulad ng sinasabi natin na yung gender, yung race, yung number of hours worked causes yung hourly wage. Okay, and it's not vice versa. And the direction is very specific. Identified natin yung independent variables natin at saka yung dependent variable, naka-identify yan. Ito class, agnostic tayo, no? So, nangyari dito. Okay, can you still see the screen, class? Hello?
Yes. Yes, po.
Sorry, medyo nag-disengage yung computer ko. I don't know why. Anyway, if you take a look at this one, this is the first variable at time t, and it's equal to a certain constant intercept. Parang regression lang to, di ba? However, your regressors are si x1 din, log 1. So parang ano to, no, di ba? Autoregressive to, no? It's like an ARIMA model, di ba? Pero we're also including another variable, no? Another variable, t minus 1, that's x sub 2. And another variable, x sub 3, t minus 1 then, plus a certain error term. So we can see here that yung ano natin, yung variable natin, yung variable na to is being modeled by itself, by log 1 in this case, and another variable, log 1 then, and another variable, log 1 then. So there are three variables now, itself, another variable x2, and another variable x3, describing yung x1 natin. Okay, then you have also x sub 2. Okay, x sub 2. So you're using x sub 2, past value na x sub 2, and also x sub 1 and x sub 3. All right? So you have here x sub 2, yung mga alpha sub 2 yung coefficient na, yung intercept, and then phi21, phi22, phi23. 2 here stands for your asset 2, and the one here stands for its relationship with variable 1, yung second dito variable 2, 2 means itself, no? And 2 3 with variable 3. All right, so this is a system of equations. So parang gagawa tayo ng multiple na OLS. Okay, maraming OLS. Okay, so in a nutshell, ano ba yung steps in conducting a VAR? Okay, so first, syempre, kailangan yung plotting the time series. Then check if stationary yung data natin. Dapat stationary yung data natin, no? Of course, there are some may mga ano dito, may mga let's say how would I say discussions, no? Kasi iba hindi nag-agree na dapat stationary yung data. IO means di ba IO means you don't have to difference the data kasi stationary na siya. Ibig sabihin, if you're going to use prices here, stock prices, kailangan na log difference na yung ano, difference ng log. In other words, returns na yung dapat na ginagamit natin, no? Kasi usually pag returns, log returns usually, di ba ano na siya, stationary na siya. And of course, we can use the augmented Dickey-Fuller test to test for stationarity. Then we determine the optimal log length. Ano yung ibig sabihin ng optimal log length? Ano yung log that will best predict or describe our model? Ito log 1 lang to, no? If there's a log 2, di magkakaroon ng x sub 1 t minus 2 dyan. Then x sub 2, then t minus 2, x sub 3, t minus 2. That's log 2. Alright? Ibig sabihin, ano yung log, ano yung okay. What's happening to my okay. So that's the third step actually, determine the optimal log length, and then pag na-determine na natin kung anong log dapat ang pagmo-model natin, i-estimate na natin yung model natin. Okay, since this is just like regression, parang combination siya ng time series at saka regression, OLS, we will have to conduct our diagnostic test then, test for serial autocorrelation, test for heteroskedasticity, normality of residuals, and also very important yung to know if the model is stable, yung structural breaks. And then dito pupunta tayo sa Granger Causality. So Granger Causality defines whether a variable is causing the other variable. Okay, in other words, may causality, may direction ng ano ng impact, no? Tapos and vice versa. Pwedeng kasing dalawang variables, they're Granger causing each other. So the name Granger Causality is derived from the person who developed this Clive Granger, tong test na to. So again, ang sinasabi ko kanina, parang agnostic tayo, no? We're not saying that only variable 1 causes variable 2. Dito hindi. It's possible that variable 2 also causes variable 1. So pwedeng bidirectional yung Granger Causality. Variable 1 causing variable 2 and variable 2 affecting also variable 1. So that's what we mean by Granger Causality. And then the next one is IRF. That's the impulse response function. Itong IRF class, ang tinitanong nito, kung significant ba na if we shock a variable, what will happen to the other variable? Kasi di ba may Granger Causality tayo? Sabihin natin, variable x1, Granger causes x2. Okay, so what will happen if we shock? Pag sinabing shock, parang, kunyari, baguhin natin ng increase natin na 1 standard deviation si x1. Ano mangyayari kay x2? And vice versa. Okay, so that's what we mean by impulse response function. Isa-shock natin isang variable to determine what will happen to the other variable. Okay? And then lastly, yung variance decomposition, which is the forecast error variance decomposition. We would like to see what percent of the variance of one variable is being explained by the other variable. So medyo ano din siya, related sa Granger Causality at saka IRF. And then also number 9 is forecast. All right? So yun ang yan ang VAR forecasting. And related to this is VEC-M, yung variance error correction model. So offshoot yan ng VAR. But since we will not have time to discuss that, I'm going to post again another explanation for VecM kasi kasama yung VecM sa finals niya. Alright, so these are the packages that we're going to use. So pakiload na class yung mga packages. Pag may hindi nag-run dyan, ibig sabihin, you have to install it first. No? Alright, yung iba dito, medyo alam nyo na yung Urca, nagamit na natin yan sa guards, di ba? Vars, a very important package for var. T-series, forecast also. Tidyverse, we have met this. ATSA contains data na pwedeng gamitin actually sa case. No? Plotly, readr, stargazer, ggplot, and ggfortify. Okay, I'll give you 1 minute class to please load the packages. And once you're done, kindly chat please. Pause recording ko muna. No? And then kindly remind me. So let's first load our data. What we're going to use first is a simulated data. No? So itong data na to, wala talaga siyang meaning. Simulated lang siya. But because objective here is for us not to focus first on the variable itself, but in the process. So dalawang example ko dito. No? Example 1, itong simulated data. Example 2 is a good example which makes use of a data, yung GDP and unemployment, no? Making use of the Okun's law. Yung mga economists, alam na alam tong law na to, no? So this law establishes the relationship between unemployment and GDP, no? Ang sinasabi, there's an inverse relationship between unemployment and GDP. So ibig sabihin, kapag tumaas yung unemployment, then bababa yung GDP. Okay. It makes sense naman. It makes logical sense. Kasi pag tumataas yung unemployment, meron tayong quote-unquote assets, no? Yung resources ng national assets like yung manpower na hindi na-utilize kasi unemployed eh. So, it affects the GDP, no? So, okay. So, that's Okun's law, no? All right. So, that's another example. I'm not sure if we'll be able to reach this far. However, class, okay. However, the codes are already here, and this is quite similar to the first one. So you should not have any problem with running this on your own. So if you're not able to reach that far, I'm sure you are motivated enough to explore that for yourself. Kasi magagamit nyo sa case. Okay, so let's since yung nasa project tayo, no, and nakaload na sa mga files yung y.csv, I'm just going to read that, okay, and generate this object called y, read_csv, y.csv. So we can do this without identifying the location kasi nasa project na siya, no? All right, so quickly, I'll just run everything here. Okay, so dito si y, no? You have here y1 and y2. So these are there are 200 entries, 2 columns. This is our simulated data only. The object here is for us to understand what var is. So this is a data frame siya, numeric. Okay, and then you have here the summary y1, y2. Okay, mean, median, mode, etc. All right, so let's move on. Plot natin class yung time series natin. So I'm going to convert this into a time series. Okay, so dapat ma-identify natin, gawin natin monthly data na lang, no? From 2000 January, frequency is equal to 12. No? So y1 and then y2. So time series $y1 start is equal to 2000 year 2000 January monthly frequency. All right, so let's run this so that we create y1 and y2. Okay, so y1 dito na, no? Y1 is a time series. Kanina si Y kasi ano lang to, no? This is just a data frame. Now we have a time series from 2000 to 2017. Okay, kasi 200 observations, so divide by 12. So that makes it mga ilang years, no? Mga 17, 18 years. All right. So with that, because we can now plot our auto-plot na natin si Y1. This is from GG45. Y1, Y2, and then i-C-bind natin siya. O, pwedeng itong C-bind na lang. Plot ng dalawa. Let me just run this tree. Alright, so we can see here that, okay, ito si Y1. Okay, looks like, ano naman siya, no? Looks like stationary. Si Y2, okay, and C-bind nila, no? You can see here the plot of Y1 and Y2. Okay, any questions so far, class? Okay, so far, you're good. Right. Now, normally, class, you know that I do not usually just give out the codes. I want you either to write them on your own or just give you a copy of that. Kaso ngayon talagang medyo pressed for time na tayo. Okay. All right, good. So check muna natin, class, yung ACF, PACF nila, no? Kasi makikita natin sa PACF kung may AR process dito, right? Sa ACF naman kung may MA process. By the way, no? Yung var class, meron din tinatawag tayong var max. No? Ano naman yung var max? Kasi var tayo di ba? Varma pala, sorry. Iba yung var max. No? Var yung inaan natin ngayon, vector autoregression. Meron ding vector autoregression moving average. Varma yun. Where you include past error terms. Okay, parang ARMA siya, no? ARMA. Pero vector na. Kasi di ba yung sa atin, VAR ngayon, di ba? Vector autoregression. We're just using the past values of itself, yung log values niya, in order to model each of our time series. Pero pwedeng VARMA din yan, no? Isasama natin sa yung moving average na component ng model. So mas complicated yan kasi parang ARMA siya na vector na, no? Maraming time series tayo. Tapos meron ding VARMAX, no? RMAX, no? Arimax kung tawagin na lang isa. Ano naman yan? Yung Arimax na yan, plus. Basta may X, ibig sabihin merong extraneous na variables na sinasama. Okay? So kunyari, meron tayong tatlong variables na minomodel, meron pa tayong sinasama na ibang variables na hindi kasama dun sa minomodel natin. Extraneous variables siya. So that's a VARMAX model. Kunyari, tinitingnan natin GDP, unemployment, at saka inflation. Kunyari lang And then dun sa model natin, may sinasama pa tayong, let's say, mortality rate o birth rate, no? Kasama dun. Hindi naman natin sinasama si mortality rate o si birth rate dun sa system of equations natin, sa pag-model natin. So that birth rate or mortality rate becomes an extraneous variable. So ang tawag na ngayon doon, VARMAX na, or ARIMAX. Others call it ARIMAX. Okay? So extension lang yon. Pero class, once you get the hang, basta nalaman nyo yung VAR, yung vector autoregression, yung iba extension na lang yan, parang dadagdag lang tayo ng mga variables to explain your variable of interest. Ba? Pag may MA yan, VARMA, ibig sabihin kasama yung error terms, no? Pag may X, VARMAX, ibig sabihin may iba pang variables na hindi kasama dun sa vectors natin na sinasama natin as regressors. So ganun lang, no? Okay, so let's plot this. Tingnan natin yung ACF at saka PACF ni Y1. Okay. So we can see here that, okay, may significant, siya dito. Sa ACF, okay, so mukhang wala namang may isang significant siya dito, no? okay, ACF, which indicates that may MA component, no? Yung PACF naman, which tells us kung AR to, may significance siya at the first lag. Yun lang, no? At lag 1 lang significant siya. Okay. So si ano din, si which tells us that if we were modeling this, baka pwedeng ARMA to, no? ARMA model. Ganun din si Y2. So let's linagay ko na dyan, ano? Significant at lag 1. Pero mukhang hindi naman slow decay. Mali yata yung paglagay ko dyan. Okay, yung ano niya, yung ACF ni Y2, ito, slow decay siya. No? Slow decay. Dito, significant at lag 1. Okay, so very, very apparent dito yung AR component, no? Based on the PACF. So both for Y1 and Y2. Okay, so kaya sabi ko dito, ACF and PACF plots seem to indicate an AR1 process for both Y1 and Y2. Okay, clear yun, class? By now, I hope clear na sa atin na if we want to determine kung AR process yung time series natin, then we look at the PACF. And true enough, si Y1 at saka Y2, may significant spike sila, significant autocorrelation sa lag 1. Okay, and then wala na, it peters off. Wala nang, sa iba wala na. Pero yung PACF, mukhang may slow decay siya, it peters out slowly. Okay, which indicates really that this is an AR process. Kasi kung MA yan, may significant spikes din siya, tapos cut off na kagad. No? Right. But we're not here to model yung ano, no? We're not doing ARIMA model here technically. We're using, we're plotting the ACF and the PACF to see the system itself. Okay, so we can now make use of, alam na natin to, no? Hindi na natin i-run tong question mark na to, yung from the T-series package, yung ADF test ni Y1 at saka Y2. So i-run natin to. So si Y2 class, hindi na si Y1. Si Y1 muna. Augmented decay Fuller for Y1, ADF test for Y1. Okay, we can see here that the p-value is 0.01. The null hypothesis is that the time series is not stationary. So we reject the null hypothesis that the time series is not stationary. Alternative hypothesis, stationary siya. So okay tayo, no? Kasi sabi ko kanina, class, pag nagva-var tayo, dapat stationary yung data. Okay? Others will contend that you have to convert first the data into a stationary data series in order to make use of the var. Di ba, obvious naman yun, di ba? Kasi di ba, bago tayo mag-AR process, kailangan stationary muna yung data natin. So same thing class, pag vector na siya. Pag vector autoregression. So also for Y2, ganun din, same conclusion. P-value is 0.01, so we reject the null hypothesis that Y2 is not stationary. Okay, stationary si Y2. All right, so the next step, step number 3, after we have converted our time series or made sure that our time series is stationary, we go now to the optimal lag length. Okay, ano yung optimal lag length? Gagamitin natin si vars package and then use this function var select. Si var select, sasabihin niya sa atin kung ano yung significant lags, no? Ano yung pinaka-significant na lag? Ano yung pinaka-maximum na significant na lag? Okay, to establish a relationship yung sa AR relationship natin. So we make use of this var select and we create this object called lag. Okay, so si Y class, di ba? Si Y is our object consisting of Y1 and Y2. Tapos gawin na lang natin lag.max is equal to 5. We can of course increase this 10. The default I think is 5, no? Okay, so pag 10 class, although it's not good anymore to have a very wide lag kasi mas magiging, imagine kung yung model mo may 10 lags, di ba? So you're trying to predict your variable making use of the past 10 values. So medyo, and usually naman class hindi na umaabot sa mga ganyang no? Sa malalaking lags. Okay? So let's just illustrate your lag.max. Okay, so let me run this first. So ipiprint yan, no? Okay. And then papakita dito yung mga AIC nila, Akaiki, Hanan Twin, Schwarz criterion, FPE. So all of this indicates that ang choice dyan, the lower the better. Okay, so for example, si AIC, if you compare log 1, log 2, log 3, log 4, okay, si log 10 nga, positive na eh. No? So which is the least AIC? Turns out that log 1, yung pinaka-least na AIC, yan, negative 0.06. Kasi si log 2, negative 0.04 na eh, di ba? So mas maliit itong negative 0.06 nito. And as you increase the log, tumataas yung AIC, yung information loss. Alright? And the summary here, ito, makikita natin, yung log, if I run this log, yan, log selection, based on the 4 methods, AIC, Hanan Quinn, SC, at saka I forget the FP kung ano ibig sabihin. But very consistent. Minsan nag-iiba-iba sila, magkakaiba. So just choose the most. No? Kunyari, AIC, HQ, SC, consistent, si FPE, hindi. Then, piliin na natin pinakamarami na pinapropose na method. Na log, I mean. Okay, so we're going to make use of log 1. No? Kasi yung sinasabi ng log selection natin. So we're going to model our vector, our variables, using log 1. So, in other words, ito yun. Parang ito yung model na yun. This one. Because this is log 1. Kasi kung log 2 yan, meron pa tayong x sub 1 t minus 2. Okay? So how do we now model this? Madali lang, class. Very easy. Ito lang. Model. So we're creating this model. Let's call it mod 1. And then we're going to use the var function. And then this is the data that we're modeling y. P is equal to 1. Ibig sabihin log 1 to. Type is equal to none. Parang nag-ano tayo na walang mean, walang intercept. No? Okay, so dalawa lang titingnan natin, either no mean or with mean. Usually with mean ang ginagawa. Let me just show this to you. So, ang model natin ito. So let's take a look at our model. All right. So ang endogenous, no? Endogenous variables are variables that are described or explained in the model. Kasi 'di ba, ito var to, 'di ba? So we're trying to model y1 and also y2. Okay? Yun ang var natin, y1 and y2. Okay? Tapos ito roots, no? Roots of the characteristic polynomial. This is just similar to the unit root test. So dapat hindi equal to 1 siya. Di ba? If you recall yung unit root test natin. So this is okay. Ibig sabihin stable yung model natin. Okay? So estimation results for equation 1. y1 is equal to y1 log 1 plus y2 log 1. So log 1 kasi to, di ba? So ang var natin at log 1 is we're modeling y1 at time t is equal to y1 t minus 1 and y2 t minus 1. Okay? So ito yung ano niya, ito yung estimates niya. As you can see here, the log 1 of y1 itself is a significant predictor, while the log 1 of y2 is not a significant predictor. Hindi siya significant, no? So, multiple r squared, adjusted r squared 6% lang. How about y2? So you can now see here that dalawang models to, no? Dalawang OLS to. Yung isa, rine-regress natin si y1 on log 1 of itself and log 1 of y2. Okay? So dalawa yung predictors natin doon. Tapos ganoon din kay y2. y2 is equal to, i-regress natin siya on y1, log 1 ni y1 and log 1 ni y2 itself. No? Value niya mismo. Okay? So you can see here that y1 log 1 is a significant predictor. And so is y2. Okay, so makikita natin dito that we can make use of, in modeling y1, we can make use of log1 ng y1, but not log1 ng y2. On the other hand, si y2 naman, pwede natin gamitin yung log1 ni y1 itself, ni y1 pala, and log1 ni y2. Both are significant. Okay, let me pause for a while. Any questions, class? Clear ba yung VAR na yan, yung vector autoregression? Okay, how about the others? Okay, good. Let me give a few more seconds to the others to signify to give feedback kung so far clear ba, class. So in a nutshell, class, thank you. Anong kaiba nito sa ARIMA? Well, si ARIMA, ano lang, univariate siya, ba? Univariate. So you're modeling the time series, you're using its log values. Okay? Pag var naman, you're using other time series, kaya multivariate siya. Hindi lang natin ginagamit yung ano niya mismo, yung auto, yung itself, but we're also using other variables. Okay, so that separates this var from an AR. No? Autoregressive, univariate, var, multivariate. All right. Okay, so meron ditong covariance matrix, correlation matrix. No? You can see here the correlation ni y1 and y2. 0.04 lang. Okay. So let's now try this. Pareho lang to ng una, no? Ang nabago lang dito, maglalagay tayo ng intercept. So your model will look like will have an intercept, a constant. So let's run this. And we have this. Okay, yung roots din natin, okay lang, less than 1. And then, okay, so halos pareho lang naman, ano? Hindi pa rin significant si y2 log 1 as a predictor of y1. Okay, yung constant hindi rin naman significant, pero still, if we're going to use this, we can make use of this value for our model. On the other hand, okay, si y2 naman, yan, may constant din dito, still significant pa rin. Okay, and the constant is not significant. Okay, so whether you use the without constant or constant, actually it doesn't matter naman masyado kasi this is not anyway another variable. But strictly speaking, tingnan natin AIC, no? AIC ni mod 1, compare natin at saka ni mod 2. Oops. Check ko lang mod 1, mod 2. If we're going to base it on AIC, okay, mod 1, 1107, 1109. Okay, it turns out that mod 1 is the better model kasi by virtue of having a lower AIC. Okay, but let's not quarrel about that. What we're going to use in this discussion, let's just use the other one with model 2 na lang tayo. Hindi naman ganun kalaki yung difference sila. Okay, I just wanted to test, hindi ko pala na-test on kung but usually ang ginagamit naman talaga yung with constant. All right. Okay, so let's print. Okay, Stargazer, si model 2. Yung, kasi si model 2, di ba? If we take a look at names, model 2. Ano ba laman itong model 2? Ayan, number 1 yung var select, no? Var result pala. Okay, so i-print natin to, yung var result na to, dito using Stargazer. So mod 2, And then i-subset lang natin yung var result, this one. And then type is equal to text. If we run this, generate lang siya ng table. Okay. So ito yung y1, ito yung y2. Okay, so you can see for y1, okay, dependent variable y1. Kay y1, ang significant predictor lang si y1, hindi significant si y2. Okay, for y2, ang significant predictor si y1 log 1 tsaka si y2 log 2, both at the 1% level of significance. Okay, we can see here the value of the adjusted R squared. All right. Now, for a var class, we're not really interested dun sa ano eh. Unlike sa regression, na we take time to interpret yung mga parameters, yung mga coefficients. How much one change of your independent variable, one unit change in your independent variable will cause a change in your dependent variable. Okay? We're not really much after that. What we're interested in are yung causality, Granger causality, at saka yung impulse response function, at saka yung variant decomposition. So let's go first to our diagnostic, since this is an OLS actually. So check muna natin kung okay yung model natin. So the first test is for serial correlation. So we can make use of the, from the VARS package, we have the serial.test. Okay, and the null hypothesis is that there is no serial correlation. Of course, we want the model, we want the residuals to not be serially correlated. Okay, so gagamitin natin itong type ng pt.asymptotic. Okay, so serial.test, model 2 yung ginagamit natin. And then yung logs na inaang natin na 10, pwede namang any number yan. Huwag lang masyadong malaki. Okay, and then serial 1. Right, so we have this Portman-2 test. Right, ang null hypothesis dito is that there is no serial correlation. And dun sa residuals ng model natin. With the p-value, no serial correlation, with the p-value greater than 0.05, then we fail to reject the null hypothesis. Okay, so there is no serial correlation, which is good. No? Okay yung model natin ng VAR natin. Okay, no serial correlation. All right, then we go to yung constant variance test ng residuals natin. The null hypothesis is that there is no the residuals, the variance of the residuals are constant, so homoscedastic siya. Okay, and then we use, if you recall the arch test, kasi pag heteroscedasticity ng time series, di ba, ang ginagamit natin yung presence ng conditional heteroscedasticity yung volatility. So we use the arch test, okay, model 2, and then multivariate that only is equal to true, kasi multivariate tayo. Then arch 1, we run this. So we can see here that there are no arch effects, no? Walang conditional heteroscedasticity. Okay, so okay tayo. Yung residuals natin are homoscedastic. And then thirdly, yung normality na residuals. Okay. All right, so we can make use of the Yarkibera test, skewness and kurtosis test. So yung normality test na to will give us 3 results. Normality based on the Yarkibera, skewness at saka ng kurtosis. Ang null hypothesis is that the residuals are normally distributed. So let's run this. Okay, so based on the JD test, okay, the p-value is 0.6221. So we fail to reject the null hypothesis that our residuals are are normally distributed. So normally distributed yung residuals natin. Among all the tests ng serial correlation, heteroscedasticity, si normality ang pinaka-least significant. No? So sometimes, kunyari sa case nyo, lumabas na not normally distributed, okay lang yun. Hindi siya masyadong malaking impact. No? Especially if malaki yung data set mo. And also test for skewness and kurtosis, same thing. No? Very consistent na based on measure of normality based on skewness. So dito makikita natin based on skewness. Okay? Hindi rin we fail to reject the null hypothesis that the residuals are normally distributed, also with kurtosis, since their p-values are greater than 0.05. Okay, so what we have done so far is to check for autocorrelation, check for heteroscedasticity, and check for normality of residuals. Pause muna ako, class, to allow you to catch up. Baka masyado akong mabilis. Okay, kindly chat please if so far so good, class. Ito yung finals nyo, ito, class. Ito yung ginagawa natin. Ang difference lang, syempre, hindi kayo gagamit ng simulated data. Gagamit kayo ng actual data. And then, may pinagbabasihan tayo. No? So, look for a journal article. Parang introduction na to sa thesis nyo eh. Kasi sa thesis nyo, kailangan may basis tayo. May theoretical construct tayo, may theoretical basis tayo na pinanggagalingan. No? Tapos either we expand on that, or we pattern it after our specific data. Okay, so let's continue. Another test is yung roots. No? Okay, sabi natin dapat, in order for our model to be stable, dapat yung parang unit root test to, no? Yung eigenvalues niya should be less than 1. Nakita na natin to kanina. Kanina dun sa output, you can see that the roots, yung eigenvalues niya, dito kanina sa var natin. Ito class, no? Yung roots, no? 0.43. So they're far from 1. So ibig sabihin, stable yung natin, yung model natin. Okay, so where are we? Here. So roots, no? Roots. So once again, we make use of the bars package using the roots function, model2, modulus is equal to true. So i-run natin tong pangalawa, control enter, and you get the one above, no? Yung 0.43. So in terms of stability, okay tayo, no? Based on the roots. So the roots should be less than 1. Okay, so tinanong ko na dito, are the eigenvalues less than 1? If so, this indicates the model is stable, hence, okay to proceed. Okay. All right, then we can also make use of the plotting of the stability. We can make use of the OLS, ordinary least squares cumulative sum. Okay, so pwede natin gamitin yung stability function ni vars. Okay, i-plot natin si stability, run natin to. And we can see here that, okay, so si Y1 class, since hindi siya lumalabas dun dito sa confidence interval na red, ibig sabihin okay, no? Stable yung model natin, stable yung var natin for Y1 and also for Y2. Okay, take note, ano siya yung system to, no? OLS cumulative sum of the equation Y2, OLS cumulative sum of the equation Y1. Kapag merong kapag lumalabas dun sa confidence interval, ibig sabihin, there might be some problem with stability. Okay? All right. Okay. Okay, so that brings us now to step number 5, yung Granger Causality. So dito titingnan natin kung which variable is causing which. Is Y1 impacting Y2? And is it Is it unidirectional? Pag sinabing unidirectional, Y1 causes Y2, but Y2 does not cause Granger cause Y1. or y2 Granger causes y1, but y1 does not Granger cause y2. So that's what we call unidirectional Granger causality. Okay, yung bidirectional naman, y1 Granger GC, pag nakita yung GC, that's Granger causes y2, and then y2 Granger causes y1. Okay, so pareho silang they affect each other, they impact each other. Alright, so ito class, kita nyo na this is different from OLS kasi si OLS class naka-identify eh. We identified ano yung dependent variable natin at saka ano yung independent variable natin. And we don't reverse, no? Hindi tayo kumukuha ng bidirectional. Walang sense para mag Granger causality kung OLS yung tinitingnan natin. What I mean by OLS is that naka-specify kung ano yung variable of interest natin, yung dependent variable natin. Like yung mga OLS natin dati na pinag-aaralan, yung hourly wage, regressed on education, race, gender, etc. Number of years of work, etc. We didn't now look at number of years of work regressed on hourly wage. Hindi natin tinignan yun. We were clear on the direction of the relationship. It was that these independent variables were affecting yung hourly wage. Ito hindi. We are, sabi ko nga, we are acting as agnostics, no? Hindi natin alam yung behavior ng data, hindi natin tinitingnan na makaka-impact yung isang direction lang yung yung causality. So there's a theoretical basis for this class, no? May theoretical basis for this one. So that's why, for example, makakakita ka ng VAR model on unemployment at saka yung GDP or GNP. Kasi pwede natin sabihin na GNP, Granger causes unemployment. No? Pag mababa yung GNP, Gross National Product ng it tends to cause a lower unemployment. So ganun din, higher unemployment pala. So negative or inverse relationship. Okay, ganun din pag unemployment and GNP. All right, so we now go to the Granger causality. Determines which variable causes the other variable. GC, Granger causality. So, pag sinabi natin Y1, GCs Y2 or Granger causes Y2, it means that the current and past values of Y1 and the current and past values of Y2 can be used to predict the future values of Y2. Okay, and it has a smaller forecast error than a model that only uses the current and past values of Y2 to predict Y2. So, ibig sabihin yan, class, mas maganda na gamitin natin parehong si Y1 at saka si Y2 as predictors of Y2. Rating ko pag sinabi natin na Y1 Granger causes Y2, okay, it means that Y1 is a significant predictor of Y2. So it would be good to use Y1 also in addition to Y2 as a predictor of Y2. Okay, yung reverse naman niya, if Y2 Granger causes Y1, it means that it's better to use Y2 and also Y1 in order to predict Y1. Okay, kasi may Granger causality si Y2 on Y1. Alright, so let's do this. And then meron tayong instantaneous causality class. And naka-identify dito. Instantaneous causality means that Y1 instantaneously GCs Y2 if a model that uses the current, the past, and the future values of Y1 and the current and the past values of Y2. Bakit may future dito? Current and past lang yata. Dali class. Let me check this. No? Lagyan niyo muna to ng Let me clarify this. Kasi bakit may future dyan? Kasi pag predict natin si Y1, the predicted values can also be used. No? So I think that's what I meant here. No? If Y1 instantaneously Granger causes Y2, okay? If a model that uses the current, the past, and the future values of y1 and current and past values of y2 to predict y2. Has a smaller forecast error than a model that only uses the current and past values of y1 and current and past values of y2. Okay, in other words, class, instantaneous GC answers this question. Does knowing the okay, so tama ito, no? Okay, so may future class, ha? Pag alam natin yung future value ni y1, okay, and that can be done if we predict y1 based on its values of itself. Okay, so pag meron tayong future value ni y1, can we use that in order to predict y2? Okay, if it's useful to use the future values of y1 to predict y2, then we say that there's instantaneous causality. Okay, so maganda gagamitin din natin yung future value ni y1 as compared to only using the current and the past values of y1 and the current and the past values of y2. Okay, so sabi ko nga dito, does knowing the future value of y1 help us better predict the future of y2? If I know what y1 is going to do or what y1 will be, does it help pag-explain ko dito. Does it help me to know what y2 is going to know? Parang ang labo nito, no? Where did I write this? Okay, basta i-ano na lang natin, no? Basta class, sorry, medyo hindi yata maganda yung pagka-write up ko dito, no? Basta knowing the future of y1 can help better predict y2. Okay, instead of just using the current and the past values of y1. Alright, so punta na tayo dito, no? If y1 Granger causes y2 and not vice versa, then that's unidirectional. Same thing, if y2 Granger causes y1 and not vice versa, then that's also unidirectional. But if both are true, if y1 Granger causes y2 and y2 Granger causes y1, then ang tawag natin dun sa Granger causality na yun, bidirectional. Okay, let's first check if there's Granger causality of y1 on y2. Okay, so here, Granger y1. I'm creating this object, Granger y1. And what function do we use? Causality. So model 2 ulit, and ang cos y1. So, well, you very well know, mamaya, y2 naman yung cos. So let's run this. All right. P-value is less than 0.05. And the null hypothesis is that y1 does not Granger cause y2. So we reject this null hypothesis. So there's strong statistical reason to believe that y1 Granger causes y2. Okay? Tapos meron din dito yung yung instant, no? Instant Granger causality. And here, what do you have here? May instantaneous causality ba between y1 and y2? Okay, no instantaneous causality. So, we fail to reject this. No? So, merong Granger causality pero walang instantaneous Granger causality. Alright, so we cannot use the future value of y1 in order to help predict the future value of y2. Okay, no, because this null hypothesis ng instantaneous causality, yung dinidiscuss natin kanina. And the p-value is around 0.6. So we fail to reject this null hypothesis. So may Granger causality, pero walang instantaneous na Granger causality. Okay. All right. How about the reverse class? Yung reverse, yung y2 naman, Granger causes y1. So nabago lang tong ang cause natin ngayon si y2. All right? So if we run that, let's run this. Okay, what do we have now? Null hypothesis, y2 does not Granger cause y1. Okay, p-value is 0.235, so we fail to reject this. Okay, so y2 does not Granger cause y1. We fail to reject this. So the relationship in this VAR model is that there's a unidirectional Granger causality. Y1 Granger causes y2, but not y2 Granger causing y1. Okay? So si y1 kaya niyang mag-Granger cause si y2. Pero si y2 hindi niya kaya mag-Granger cause si y1. Let's review yung model natin kanina. No? Okay. So let's take a look at this. So consistent ba yung dito, class? Take a look at this. Di ba dito si y1 significant predictor ni y1. y1 log 1. And y1 log 1 is also a significant predictor of y2. Okay, so consistent siya dito no? sa bar model natin. And here, y2 does not Granger cause y1. Tingnan nyo, not significant. Okay? So dito pala mahuhulaan na natin na which variable Granger causes which one. And that was reinforced here. Na-verify dito yan. Okay, dito, y2 does not Granger cause y1. So we fail to reject that. Okay, ganun din dito sa sa instantaneous. No instantaneous causality. So we fail to reject this. All right. Then we go to the IRF. No? Any questions so far, class? GC, Granger Causality. Okay, good. Good. All right, IRF, impulse response function. This is now a diagram, a plot of how shocking a particular variable will impact the other variable. Okay, so we know here that when we shock y1, it will cause a significant effect on y2 kasi alam naman natin na y1 Granger causes y2, but not for y2 on y1. So if I shock y2, anong effect niyan sa y1? Perhaps hindi siya significant, no? All right, so I'll run this. I'm creating this impulse response function 1 using again the bars package. The function is IRF. So model 2, the impulse is y1. Ibig sabihin nito, isa-shock natin si y1. And we know that most probably something will happen kasi y1 Granger causes y2, diba? So pag sinak mo si y1, kunyari may baguhin mo siya, no? You increase it by 1 standard deviation. Ano mangyayari kay y2? Okay, so you can see here, m dot ahead means yung 10 values ahead, and then bootstrap ang gagamitin na method dito. Confidence interval is 95%, then it will run, magsasimulate to, no, ng 1,000. And I think dapat yata tayo mag-set that seed dito, no, para pare-pareho tayo. 1, 2, 3. Okay, sige, mag-set that seed tayo, class. So that whatever the randomized processing will be the same for us. Iko-comment out ko na itong IRF para hindi na siya mag-run. Let's run this. All right. So we can see here, class, yung impact, no? This is the IRF, impulse response function. So what are we shown here? a 1 standard deviation shock on Y1 will affect Y2. So after 1 month, so pag nagkaroon ng ano dito, after 1 period, no, ano mangyayari? Kasi ito ay had 10 periods to. So this is at 0, no? After 1 period, makikita natin na dito yung 1 period, no? Yung effect niya sa sa Y2 is around 0.2 standard deviations. Then after 2 periods, tataas siya dito mga more than 0.5 di ba? Ito. Okay? And then it will taper off after 3 periods, 4 periods hanggang magno-normalize na siya. So yung effect ng 1 standard deviation shock on Y1 will be immediate, no? So taas siya kagad dito, taas dito hanggang period 2 and then bababa ng konti hanggang magte-taper off na siya after 10 periods. In this case, monthly kasi ang natin yung data natin. All right? And it's significant. How do I know it's significant? Because it's above this y is equal to 0 line. Okay? Yung red line na yan, class. No? Significant yung IRF kapag above the positive line. Okay, we can see that it's significant. Okay, the other one, on the other hand, tingnan natin tong si naman, yung Granger Causality ni So dito class naglagay na ako The decay in the plot illustrates that as the month passes, the effects of a shock in Y1 today decay to 0. Ibig sabihin, after 10 periods, wala na. This is to be expected in a stationary VAR models. Okay, parang di ba? Parang yung AR definition, yung after yung mga lag na malalayo na, wala na masyadong effect. Okay. So dito naman class, ito, IRF2. Okay, mag-set that C din tayo. Did you get the same set that C din tayo dito? 1, 2, 3, 4. Did you get the same diagrams by the way, class? Okay, good. Alright, ito naman, tingnan natin yung effect, yung vice versa naman, yung reverse. What will happen to Y1 when we subject Y2 to a shock? Isa-shock natin siya. Ibig sabihin, i-increase natin siya kunyari ng 1 standard deviation. Okay, pareho lang din sa function natin kanina. Tapos i-plot natin. Okay, so let's run this. Okay, and you can see here that, yan, tingnan natin. Now, take a look at the IRF, impulse response function. Notice that the reaction is negative. It's below the y is equal to 0 line, which means this is not significant. Hindi significant to, itong effect na to. Okay, although negative siya, ibig sabihin, pag sinak natin si Y2, ano mangyayari kay Y1? Turns out here negative yung effect, bababa si Y1, But this is not significant. Okay? Kasi below the y is equal to 0 line siya. Right? And this is consistent because alam naman natin na Y2 does not Granger cause Y1. Okay, so even if we shock Y2 with 1 standard deviation, we can see here that the impulse response function tell us that there's no significant effect. All right, so ito, recall that Y2 does not Granger cause Y1. Hence, the IRF function shows a 1 unit measurement positive shock in Y2. So a 1 unit, 1 standard deviation measurement positive shock in Y2 theoretically results in a negative 0.05 decrease. However, this is insignificant as the confidence interval for the lower limit falls below the yellow line. Okay? All right, and then we have this yung forecast variance decomposition, yung FEVD. This tells us, class, kung yung sa forecast errors natin, ilang percent doon ang kino-contribute doon sa variance na pag-explain ng Y1 o ng Y2, ilang percent, kunyari, sa pag-explain ni Y1, ilang percent ang ina-explain ni Y2 doon. Sa pag-explain naman ni kay Y2, ilang percent yung ina-explain ni Y1 doon. Right? So I'll leave you class to look at the what FEVD is. So let's create this object, variance decomposition. So FEVD is model 2, then 20 periods ahead. So i-plot natin to. And you can see here, yan. You can see here that the forecast error variance decomposition for, sabi natin, di ba, 20, and I had 20, and 20. Notice that FEVD for Y1, 100% of that is explained by Y1. Okay? Walang percentage dito ang ina-explain ni Y2. Why? Bakit kaya? Kasi Y2 does not Granger cause Y1. Diba? Very consistent naman to. So you can see here the contribution of Y2 in explaining the variance of Y1. On the other hand, ito, since Y1 Granger causes Y2, you notice here that may contribution si ano. In fact, dun sa N I had na 20, kaya nag-increase muna siya, and then nag-stabilize na siya. No? Yung effect ni Y1 on Y2. So this plot class is the forecast error variance decomposition, and it tells us the contribution of the other variable on the variable of interest as regards, okay, as regards explaining the variability of in this case Y1 and Y2. So si Y2, a certain percentage of that, mga ano to, around 30% yata, is attributable to Y1, okay? While for Y1, 100% attributable to Y1. Walang contribution si Y2. Okay, clear class, clear? It's almost time. Clear, at least natapos natin to. Alright, so ito class, no? Naka-explain naman to dito. Right? On the second table, we note that on the first month, the variance of the error term of Y2 is almost 100% due to Y2 itself. However, the impact of Y1 and Y2 increases over time, approximately 30%. All right. And then lastly, class, ito, pwede tayo mag-predict. So we're going to create this object, forecast 1, and then i-predict natin si model 2, say 10 months ahead, confidence interval 0.95, and then we'll create a chart, fun chart for Y1 and for Y2. So if I run this, makikita natin dito yung prediction for Y1 and Y2. You can get the values here. So I'll leave you guys to print the values here. Ito yung prediction niya. And 95% confidence interval. So this is the predicted value for Y1, and this is the predicted value for Y2. Alright? So nakapag-predict din tayo dito. And you can get the values of that. Okay, so that in a nutshell, class, is your VAR. Vector autoregression. Ang kulang na lang dito yung VECM, yung Vector Error Correction Model. So I'll post the video that explains that in relation to this one. VAR and VECM goes hand in hand. And then itong second class, itong second part, example to. I encourage you to look at this kasi ito ngayon, may actual data na to. No? Okay, meron tayong unemployment at saka GDP. Right? Unemployment at saka GDP to, and it followed the same process, just like what we did a while ago. Okay, so that ends our discussion, class, for the day, for the week, for the term. parang nagkaroon ako ng detachment anxiety. Parang gano'n na, ang bilis. Parang dami ko pang hindi na-discuss, ang dami ko pang sana gustong i-discuss sa class. But however, ganun talaga, no? Kasi limited yung ano natin, to 13. Tapos ang dami pa natin mga ano, ang dami pa mga no classes, ang dami pa mga ano. Alright, so reminder, dun sa ano natin sa Google Sheet natin, no? Maglalagay kayo doon class kung ano yung ilalagay ko mamaya kung ano yung journal article nyo, summary nun, tapos ano yung variables na kukunin nyo doon. So the case will be do a var, vector autoregression, plus if necessary yung vecm. And then the bonus is yung SEM, parang report siya on SEM. Of course, the bonus is optional. Okay, any questions, class? May natutunan ka ba kayo sa term, class? Did you learn something dun sa buong term natin? A lot, thank you. Final case, okay, deadline nga pala for final case. Ano? The deadline for final case is Sunday next week. So that will be August 16, August 13. 4, 5, August 13 class. Okay? Okay na yan, class ha? August 4, 5. 16 sa Wednesday, 15, August 13, Sunday, 11:59 p.m. Okay? So, simula na class ha? Kahit hindi ko pa nasa-set yung ano. Hanap na kayo ng kasi ano na to class, this is more an applied something. So pagdating sa FINTSAR, pagdating sa research, medyo may idea na kayo kahit paano. Isang journal article lang naman pinapaano ko eh. Or if you can find 2, okay lang. Basta ang importante, tingnan niyo yung journal article na yun. And in particular, VAR lang naman tinitingnan natin, yung vector autoregression. How it was used there, and then gagamit kayo ng data which you're going to get from Refinitiv icon. You can make use of at most class, kahit at most 3. Huwag na kayo gagamit na masyado marami. Preferably 3 variables. Itong ginamit natin ngayon, 2 lang, di ba? So, pwede kayong gumamit ng 3 variables. Okay, so I hope you learned something for the sa term class. Maraming salamat. I enjoyed the class with you. Thank you so much. Yeah. Thank you sa mga comments nyo. Salamat class, salamat. I enjoyed this class. Hope to see you in your future subjects. Okay, thank you, and keep safe. For any concerns, just PM me. See you around. Thank you.
Thank you po, sir. Thank you po for the time. See you po around. Stay safe po.
Thank you. Keep safe, everyone. Salamat.
Hi, sir. Question lang po for the case.
Yeah, sure.
Yung hello, sir. Sorry,
Yeah.
nawala. Yung topic po, sir, kailan po namin pwede ilagay? Or
mamaya gagawin ko na yung pwede na kayong maglagay actually, no? Kahit dun sa case 2.
the right side na
ilagay doon pero maggagawa pa rin ako ng case ng finals na
lagay ko na sa baba, sir. Lagay ko na lang po sa baba ng case 2, sir. Kung ganun.
Pwede. Meron ka na? Bilis
ano po, exchange rate volatility po.
Pwede yun.
Yes po. And international trade po.
Wow. Mukhang ginamit nyo na sa eco yung dati
Hindi naman po, medyo pinalitan po ng konti. Pero yung
okay.
po ng exchange rate. So,
okay. Good.
Okay po. Thank you, sir.
Alright, sige. Thank you.
Bye, sir.
Yes, bye-bye.
Sir, excuse me, sir. I wasn't able to say my name during the attendance check, sir.
Attendance? Okay.
Yes.
Same po,
What's
sir.
your
Ferry
name?
Munoz.
Sue, sir. Starts with A.
Elijah. And who else?
Sue, sir.
Sue.
Yes, sir.
Right. Yan. Okay na.
Thank you so much, sir.
Thank you.
Thank you, sir.
Thank you.
Hey, sir, I have a question po for case 3.
Yes, yes.
Is it about Philippines lang po dapat, sir? Or pwede man pong
As much as possible sana Philippine data.
okay po.
Pero kung
Okay.
kung ipa-approve yung sa akin, i-PM mo kung ano.
Sige po, sir. Sir, may nahanap po ako relationship among world oil price, exchange rate, and inflation in the Philippines po.
Pwede yun, pwede. Oo,
Pwede yun, sir.
Pwede yun. Oo. May back bar na siya. Ay, magagamit na. Actually, madali na nga yan kasi may codes na tayo di ba?
Yes po, sir. Yes po.
You just
Sir, naka-recording pa po pala kayo.
Ay, sorry.
Okay lang po, sir. No problem po.